Alright, welcome back to part 6 of my little tree generation series. And last time we created the skeleton for this tree generation algorithm that I'm going to implement. And we set this segment count here to be equal to the length of the tree. But actually what I want to keep inside this counter here is actually not the tree of the length, because yeah, it goes into the segment here. So that was kind of a mistake. So what I want to do instead is to move this to the beginning here, and in order to not have this drag all the way across here, I'm gonna just decouple it there and pop it in here. So the trick is we're gonna constantly update the number of segments every time we add a point or a segment to the tree. Then we're going to update this. So let's go ahead and build the generate tree function. So we're going to create a function called generate tree. And the generate tree is going to be taking care of all the, it's going to take care of the initial call to major function we are going to call generate a branch. Okay, so generate tree is going to call generate branch. So let's drag that out. And it's kind of just gonna work this way, but generate branch is gonna take in a parameter for generate branch. Okay, wait a minute. I wanted to put that here. Great. All right. So inside generate branch, we want to get the current index in the tree. So it's going to take in an integer. It's just going to call this index. And what this index is the number or the pointer to the current branch in the tree list. So initially we don't have, when we call this, we don't have anything inside our tree. So we need to add a node. Actually, what we can do instead, I think we can set this tree. Yeah, this is better. So we can set this tree and then make an array with a 0 item, and then we can make a tree branch. So a tree branch is a list of points, parent index, and a parent width scale. So we added segment length and branch length factor and so on. So what we need to do is to expand the tree branch with that variable. You can call this the parent length. We can discuss the names if they're good or bad, but hopefully it's going to be clear what it is. So the parent length is going to be whatever we set initially. So it's going to be the segment length. And remember, we have the branch length factor, which we're going to multiply every time we call it. So it's just going to gradually become smaller. And we're going to set the parent width scale to a 1. So this is kind of different because it's a scale, not an actual size. So the parent index, we could actually set this to -1 here, and then we need to create one dummy point, and we're going to just get a dummy point by dragging out the turtle and say get relative transform. and actually make an array of points and add that single point in here. So that was the initialization of the tree, and then we start to call the tree. So let's go in here. Let's see, was it overkill to put it in here? Let's see. I think it's okay. Let's just keep it this way. So generate branch. This is the next major function. This is where all the magic is gonna happen, really. Actually, no. Let's do that at the end. So what we want to do at the beginning here is to get the branch definition for this index here. So we're gonna get that branch definition here. And I'm gonna add a sequence here because I know already that this is gonna take up some space, and I kind of want to keep some of the initialization. Whoops, I didn't want to do that. I wanted to add a comment up here. Initialization. So this stuff here is going to keep all the stuff that we need to do in the beginning. And let's break this open. And here we have some of these things, and the trick is that we're eventually going to get more of them. So in order to keep things nice and tidy, I like to do this way. So one thing for sure that we need to save is the, let's see, the parent width. So we're going to promote this to a local variable and call this local width scale. And we are going to promote this to a local variable as well. I'm going to call this local length. And let's see, how can we do this without making a mess out of it? Maybe something like this. Yeah. Maybe okay. I think this is gonna do for now. So we also want to keep the current index inside. So let's drag one of these out and promote to a local variable. So put it here. Okay, I'm just gonna call it index. So hope you guys know what I mean by that. So actually what I'm going to do is drag that one up, and I'm going to put it here and disconnect this one. There we go. Beautiful. Beautiful. All right, so what we need to do in here is really to enumerate the number of segments, and we have segments per branch here. We have that number here, and let's see, since we need to decrease this every time we branch, we actually need to keep this inside our struct. So we need to revisit the tree branch and add segments. segments per branch, which is going to be an integer. And we also need to set that out here. And initially it's going to be the same as we have in our public variable. And whoops. Then we also need to get this out here and promote that to a local variable. Oh dear. Right, so let's call this local. Yeah, well, local segments. That's local segment count. Segments per whatever. I just hate all these long names, but it's definitely more descriptive. So we're gonna make a for each or for loop going from 1 to that number. Okay, and I don't know if I called it an initialize tree. Nope. So generate tree, and get rid of this one now, and generate tree calls this one with index 0, and then we're going to start looping. Let's see. Okay, so the next thing we should determine is when we should branch, and we have this branch frequency, which we also have set somewhere. So every time in this case, every second segment, we want to make a new branch. And the way to do it is by taking this index, which is going to go from 1 to, in this case, 4, and it's going to count 1, 2, 3, 4, and at 2 it should generate a branch, and at 4 it should right now generate a branch, but I think I'm going to take out the last one anyway. So what I'm going to do is to say use the modulus for that, and say if the modulus of this is equal to 0, then we want a branch. But actually we want to add something here, and we want to say and, because we don't want to branch if the index is equal to the local segments per branch, because it looks weird if we can actually see this in the drawing I made. If it's going to go up here and then make a branch that way, I would say I would have preferred it not to generate this part here. So I'm going to take it out by saying if this index and index is less than a local segments per branch. Okay, so let's make a comment box. Whoops. Let's make a comment box and call this branch, and move forward and draw. So So this is going to be the instruction for our turtle. Okay. Right. Let me see how long we've been going. We have 15 minutes on the video. Just want to see if I can maybe flesh out the branch part here before I end this video. Let's do it. So in this part here, we want to actually create a new branch. So when we create a new branch, we just make a tree branch. And then we want to add this to the tree. Add this to the tree. And we want to set a few things for this. So one of the things we want to set is almost the same things as we have out here. So I'm just gonna copy most of this here and pop it in here. There you go. So let's take a look at what we have here. So we have the segment length. Now the segment length is going to be decreased eventually. Actually, we need to decrease it here. So we actually need to do a little calculation on this. So the segment length, we want to multiply by the segment length factor, which, if we remember, is 0.8. So it's going to take the 20 and turn it into 18. I'm terrible with math. What? $16. What the fuck? Okay. So it's going to turn this into 16. And the segments per branch we also need to decrease. So we're going to take the decreased segments at branch and say minus that. And then we have this, the parent index, which is going to be the local index, our current local index. And we're missing the parent width scale, which we're going to get from the local width scale here. And the local width scale, since the way I do it here, I'm going to decrease it at every segment every time I move forward. So it's something I will update in this section down here. So it's not, I'm not going to do any calculation on that. And finally, I'm going to add it, and then I'm going to set. Then I actually got to call this same generate branch again. So this is where it becomes recursive. And let me already say that I hate debugging things, recursive functions, because it breaks my head when I need to think about this. So let me quickly add a comment here. Generate branch. So that should be the generation of the branch. But you still need a few things more. I'm just going to make some more space because I already know that I forgot something. But I think I'm going to keep this for now because it's going to be okay. And next time we're going to continue implementing this forward draw and add some of this stuff I didn't do here, which is one of the things is the roll and the yaw and all that stuff. So let's take a break here and continue in the next. Bye bye.